Most people assume that what limits a window air conditioner is the electricity flowing into it. But what actually determines how hard that machine has to work is the temperature of the air it is dumping heat into. Change that one variable, and everything else changes with it. That is the whole idea behind what I am going to show you today, and it is simpler than almost anyone realizes. I have watched folks spend good money chasing efficiency upgrades, programmable thermostats, extra insulation, ceiling fans, and miss the single biggest lever they had sitting right outside their window the whole time. The ground beneath your feet stays at roughly 50 to 55 degrees Fahrenheit year-round, just a few feet down. Traditional geothermal systems cost tens of thousands of dollars because they tap into that stable temperature through a big installed loop and a dedicated compressor. But the underlying principle, use the earth as your heat sink instead of hot outdoor air, can be applied to a plain window unit for a fraction of that cost. I have done this myself, I have helped neighbors do it, and I have seen it make a real, measurable difference in how hard a small AC has to run and how cool a room actually gets. If you want to go deeper on what we cover here and get the fuller breakdown that this video can only begin to touch on, open the camera app on your phone right now and point it at the QR code in the top right corner of your screen. That QR code stays pinned up there for the entire video, so you do not need to pause. Just scan it whenever you are ready. It will take you straight to the guide, where the more detailed answers live. Now, I want to be honest with you about something before we go any further. There are two myths I hear constantly when this topic comes up, and both of them will cost you time and money if you believe them. The first is that running water over your condenser coils is going to burn up your unit or void the warranty in some dramatic way. That worry is largely overblown for older units used in a DIY setup like this. We are not modifying internal refrigerant lines. We are just changing what the outside of the condenser exchanges heat with. The second myth is that any kind of evaporative spray or wet coil trick gives you the same result. It does not. Spraying warm tap water on a hot condenser helps a little. Running water pre-cooled by a buried ground loop helps a lot. The temperature difference is everything, and I will explain exactly why in just a minute. By the end of this video, you will understand the real physics driving this project. You will know every material you need and roughly what it costs, and you will have a clear picture of how to do this yourself over a weekend. You will also know what not to do, because there are a couple of mistakes in the installation that quietly undo the whole thing, and I will point them out as we go. The one that I see trip people up most often is coming toward the end, so stick with me. Let us start with the basic physics, because once you understand this part, the rest of the project makes perfect sense. Every air conditioner is a heat pump in reverse. It moves heat from inside your house to outside. The indoor coil absorbs heat from your room air. The refrigerant carries that heat to the outdoor condenser coil. The condenser coil dumps that heat into whatever medium surrounds it. In a standard window unit on a hot day, that medium is 90-degree outdoor air. The refrigerant inside has to get hotter than that outdoor air to push the heat out, which means the compressor has to work harder, draw more current, and run longer cycles. The hotter the outdoor air, the harder every part of the system strains. Now imagine that instead of 90-degree air, the condenser was shedding heat into 55-degree water that just came up from a buried loop in the ground. The compressor barely has to strain. The heat transfer happens quickly. The unit cools your room faster, runs shorter cycles, and draws less power doing it. That is it. That is the whole idea. The expensive part of a real geothermal system is the drilling, the high-efficiency compressor, and the professional installation. We are keeping the cheap window unit and just giving it a better heat sink. Now let us talk about what this project actually costs, and what you need to pull it off. The window AC unit itself, a decent 5,000 to 8,000 BTU unit, runs somewhere in the $150 range new, and many folks already have one sitting in a closet or a garage. Beyond the unit, you need a small submersible or inline water pump, the kind used for small ponds or recirculating fountains, which runs roughly $20 to $40. You need about 50 to 100 feet of half-inch polyethylene tubing, the black flexible kind sold in rolls at any hardware store or farm supply, which will cost you somewhere between $15 and $30 depending on the length. You need a few basic fittings, a small plastic tub or bucket to act as your reservoir, and enough garden hose to reach from the tub to the unit and back. All in, the add-on system costs somewhere between $60 and $100 if you are starting from scratch. If you already have a pump or some tubing sitting around, it is less. This is not a complicated bill of materials. The ground loop is where the magic happens, and I want to spend some time here because getting this part right is what separates a project that really works from one that disappoints. You need to bury your tubing at a minimum of 4 feet deep to get stable ground temperature. 6 feet is better if your soil and your back will allow it. The longer the buried section, the more heat the ground can absorb from the water circulating through it. I recommend burying at least 40 feet of tubing. You can coil it horizontally in a trench to make it manageable. Dig a trench about 4 feet deep, and as long as you can manage in a straight line or a shallow curve away from the house. Lay the coiled tubing in the trench, backfill it, and tamp the soil back down. One end of the tubing comes back up near the AC unit. The other end drops into your reservoir tub. The water in the loop is constantly being cooled by the earth around it on one pass, then returning to be cooled again. It sounds almost too simple. It works because the ground at that depth is essentially a giant, passive heat exchanger that never needs electricity to maintain its temperature. It just sits there at 50 to 55 degrees, season after season. If you want to go further on the sizing and layout of that buried loop, how to adjust the depth or the coil length for your climate and your soil type, the guide covers that level of detail that I simply cannot get into here. Open your phone's camera app, point it at the QR code still sitting in the top right corner of the screen, and scan it. The fuller breakdown is right there waiting for you. Connecting the ground loop water to the window unit is the step most people are nervous about, and I understand why. You are combining water and electricity, and that naturally makes careful folks pause. The key is that we are not putting water inside the unit or anywhere near the electrical components. We are running the cooled water through a coil of copper tubing that wraps around the outside of the condenser section, the part of the unit that sticks out the back of the window. Copper is ideal because it transfers heat quickly. You wrap 3 to 5 tight coils of 1/4-inch copper refrigeration tubing around the condenser fins, secure it gently with a few plastic zip ties, and connect the inlet and outlet ends to your ground loop tubing using simple push-fit fittings. The pump circulates the cool groundwater through the copper coil. The copper coil pulls heat away from the condenser, and that heat is carried back down into the earth loop where the ground absorbs it. The condenser fins stay dramatically cooler than they would in open air. The refrigerant inside does not have to work nearly as hard to shed its heat. The compressor cycles less. Your room cools faster. One thing I want to be clear about: keep the copper coil on the outside of the unit's housing, in the outdoor section only. Do not let any water contact the fan motor, the electrical box, or the indoor coil. Use weatherproof outdoor rated connectors anywhere you have a splice near the unit. This is not a finicky build, but basic electrical common sense matters here. Water and live circuits do not mix, and a little care in the setup means you never have to think about it again. Let me talk about the pump and the reservoir setup, because this is where the system ties together. Your reservoir tub, Even a 5-gallon plastic bucket works, sits either near the unit or just below it at ground level. The pump sits inside or beside the reservoir and pushes water through the copper condenser coil, where it picks up heat. That warmer water then flows down the tubing into your buried loop, where the earth cools it back down and it returns to the reservoir. The cycle is continuous while the AC is running. You want a pump with enough flow to keep the water moving steadily. A pump rated for 100 to 200 gallons per hour is plenty for this scale. Too much flow, and the water does not spend enough time in the ground loop to cool down. Too little flow, and the condenser coil stays warm. Somewhere in the middle is right, and the low end of that range usually performs well in practice. You will lose a small amount of water to evaporation over time, so check the reservoir level every week or two and top it off. Some folks add a float valve connected to a garden hose, so the reservoir tops itself off automatically, the same way a toilet tank refills. Simple and effective. If you live somewhere that freezes hard in winter, you either drain the outdoor system before the first hard frost, or add a small amount of food-grade propylene glycol, the same non-toxic antifreeze used in camper plumbing, to the reservoir water. That is the full winterization plan. It takes about 20 minutes. Now, here is the thing I promised to show you. The mistake that quietly undoes this whole project for a lot of people. The problem is thermal short-circuiting in the buried loop. What happens is this. Folks dig a trench but route the return line, the warmer water coming back from the condenser, right alongside the supply line, carrying the cool water up from the deeper ground. If those two runs of tubing lie touching each other in the trench, the warm return line reheats the cool supply line before it ever reaches the condenser. You lose a big chunk of your temperature advantage before the water even does its job. The fix is simple. Separate the supply and return lines in the trench by at least 6 inches of soil. Lay them in a slight V shape if your trench is wide enough. Or put your outgoing return run on the way to the deep coil and keep the supply run on the opposite side. Either way, keep warm water away from cool water in the ground. That one detail accounts for a large share of the performance difference between systems that impress people and systems that barely seem to do anything. If you want to go deeper on fine-tuning the loop layout, including how to adjust for clay-heavy soil versus sandy soil, which affects how quickly the ground absorbs heat, the guide is exactly where I would point you. Your phone's camera app pointed at that QR code in the top right corner of the screen gets you there. It goes further than I can here, and if you are planning to build this, the fuller picture is worth having. Let me give you a realistic picture of what to expect once this is running. A standard window unit working against 95-degree outdoor air has to push its compressor hard and often runs almost continuously on a hot afternoon. The same unit with a 55-degree ground loop supplying the condenser runs shorter, more efficient cycles. The room reaches your set temperature faster. The unit may run only half as long to maintain it. Exact results vary depending on your climate, your soil, the depth of your loop, and the condition of the unit itself. But the directional improvement is consistent and real. The deeper and longer your buried loop, the better the result. Many people find the room stays cooler than it ever did with the window unit running solo, even on days when the outdoor temperature would have had the old setup struggling. At around 2/3 of the way through a full community of folks who are building and refining setups like this one, questions come up that I try to answer, things I have not covered in any single video. If you want to be part of that and get answers specific to your setup and your climate, take a moment to subscribe to this channel. That is where the ongoing conversation lives, and I do my best to respond personally when I can. From a maintenance standpoint, this system asks very little of you. Check the reservoir level every couple of weeks. Flush the copper coil with clean water at the start and end of each cooling season to prevent mineral buildup, especially if you are in a hard water area. Inspect the buried tubing connections once a year when the soil is dry enough to expose the entry and exit points. Beyond that, there is no filter to replace, no refrigerant to recharge, no professional to call. The ground loop itself will last decades. The pump is the most wear-prone part, and a replacement pump costs less than $30 if it ever needs it. Let me bring this home. The whole point of this project is that geothermal efficiency is not magic, and it is not reserved for people who can afford a $10,000 installed system. The underlying principle is just physics: cooler heat sink, easier compressor, better results. $150 for the unit, $100 or less for the loop system, a weekend of straightforward work, and you have something that outperforms what most people are paying full utility bills to run all summer. There is not a lot of money in telling folks the simple thing that actually works. The money is in selling the complicated version. So now you know the simple version. This week, price out the tubing and the pump at your local hardware store. You may be surprised how little it costs to get started. This month, plan your trench route and identify where your buried loop will go. Before the heat of next summer, you could have this running and notice the difference on the first hot afternoon. And before you go, if you want the deeper answers, the fuller breakdown of everything we covered here, open the camera app on your phone and point it at the QR code in the top right corner of the screen. It is still there. Scan it, and the guide is yours. It goes further than any single video can, and if you are serious about building this right, it is worth having in your hands. If you have ever tried something like this, a DIY cooling project, a ground loop experiment, anything that took a little old-fashioned ingenuity to beat the heat, I would genuinely love to hear about it in the comments. What worked, what did not, what you would do differently. Those stories are worth more than any spec sheet. Next time I want to talk about window unit placement, specifically why most people install them in exactly the wrong spot, and how moving yours by as little as 4 feet can change how well it cools the room. That one surprises folks every time. If this video was useful, subscribe and stick around. There is plenty more where this came from, and I appreciate you spending the time with me today.